Page 142 in the physics notes, just after the first power example. This is problem number 2, obviously. It's an interesting problem just to kind of give you an idea of how much it really costs to pay for the electricity in your house, well, what your parents pay. You might be, maybe you're not surprised, but it probably costs your parents somewhere on average between $100 and $200 a month for the electricity in your house. And the things probably that cost the most, probably the thing that costs the most for the entire year is your refrigerator, because it's used all year long, and it takes quite a bit of electricity to run it. But in the summertime, it's the air conditioner. The air conditioner, if you use it a lot, it actually might beat out the refrigerator for the entire year, just for the amount of time you use your air conditioner in the summertime. But everything you plug in, your TV, your phone charger, your computer, light bulbs, hair dryers, microwaves, all of these things contribute to an overall electrical bill, which, like I say, is probably on average $100, $200, maybe over $200, depending on the size of the house. But the cost to operate a particular device is not really that hard on a per device basis. I'm going to give you an example here, and the units are sort of strange to start off with, but they're essentially developed so that you can easily make these computations. The unit up here at the top, you can see it's what's called a kilowatt hour, KWH. It's not kilowatts per hour, but you've heard of watts before. Kilo is 1,000 watts, hours, not kilowatts per hour. And your parents probably pay somewhere between 12, with taxes and everything, somewhere between 12 and 15 cents per kilowatt hour. So I'm just going to give you an example here. Like, for example, a light bulb in part A, a 75 watt light bulb, which is a moderately bright light bulb. And most light bulbs nowadays, if you're using LED light bulbs, their wattage is less than that. But we still have a lot of the old-fashioned incandescent light bulbs. But we have a lot of light bulbs in the house. This is just one light bulb. Let's say you had one 75 watt light bulb that was turned on and left on for an entire month. How much does that really cost your parents? Now we're going to do a little bit of approximating here. We're going to let 1 month be 30 days. So we're going to say 30 days for the month. Some months have 31 days, but we're just going to make the calculation a little bit easier by using 30 days. It's not much different. So you got to figure out how many hours. So to do these computations, you figure how many hours that is. Well, that's 30 days times 24 hours in 1 day. So it's 24 times 30. So what is that, 720 hours? So the light bulb would be on for 720 hours. Now, I mean, it's not that hard to do. You look at the 75 watts and convert that to kilowatts. Well, 75 watts is, you divide by 1,000, it's 0.075 kilowatts. I'm just going to put KW for kilowatts. In other words, to convert from watts to kilowatts, you divide by 1,000. So if you want to figure out how many kilowatt hours you have paid for, you just multiply the two numbers. That's what kilowatt hour is. You multiply the two numbers. You take the kilowatts, 0.075 kilowatts. I'm going to do something I don't normally do. I'll put the units with the numerical value, the magnitude of the power. That is actually the power of the kilowatt of the light bulb, times the number of hours, 720. That's at 720 there. Sorry about that. Hours. I'm using capital H for hours because when your parents get the bill, it usually has capital KWH. I'm going to try to fix this at 720 hours. So you just multiply 720 times 0.075. 0.075 times 720 is 54 kilowatt hours. So your parents have to pay for 54 kilowatt hours. That's 54 kWh to keep that light bulb lit. And now we just do some simple math here. It says it's 12 cents per kilowatt hour. In other words, if I take 54 kWh, kilowatt hours, times $0.12 per kilowatt hour, that's 0.12 $12 per kilowatt hour. It doesn't come out to be a big number, but maybe more than you thought. I don't know. 0.12 times 54. That's like $6.48. So it costs $6.48 to light that light bulb for 1 month. That might not seem like a lot, but you have a lot of light bulbs in your house. You're not leaving them all on for the entire month for 720 hours. But you might have some security lights outside that are on like overnight, and in the wintertime, overnight it's over half the 12, because it's more than 12 hours of darkness in the wintertime. And there might be some big lights on your garage and the front of your house, and they're going to be more than 75 watts. So just to run security lighting for your house, might be 20, 30, 40 bucks a month just to keep those lights on if you have a lot of outdoor lights that are on. Anyway, it gives you a little bit of an idea of how much it costs and a way to compute it. So here's another example. To cook a potato in your microwave oven for 4 minutes. I've actually done this. They didn't really come out too well in the microwave oven. I like the baked potato, for an hour in the regular oven. But let's just do the math on this for part B. It would be, once again, you just figure out how many kilowatts and how many hours. Well, 4 minutes. So now I got to do the kind of the opposite conversion. You got 4 minutes times 1 hour is 60 minutes. So it's 4/60ths of an hour. I'll put it in decimal form. 4 divided by 60, which is 0.067 to 2 sig figs. That's 0.067 hours. I'm using H for hours. And 1,400 watts is 1.400 or 1.4 kilowatts. So I think you can do that in your head. Divide by 1,000 to get into kilowatts. So how many kilowatt hours? So it's 1.40 kilowatts times 0.067 hours. This is very simple. You can do this with anything, like a hair dryer. A hair dryer is usually like 1,200 watts, maybe 1.2 kilowatts times, maybe you use it for 15 minutes. I don't know. It'd be 1.2 times 0.25 for 1 day of use. But so you can do this for any appliance if you know what the power is converted to kilowatts and how much time you have it on for converted to hours. Anyway, 1.4 times 0.067. Okay, 0.09 kilowatt hours. Make sure I did that right. Yeah, 0.094 kilowatt hours. So not a whole lot. I'm going to multiply that then by the 0.094 kilowatt hours times $0.12 per kWh. It's not a whole lot. 0.094 times 0.12. So it's like a penny. It's like 0.01. So that's $0.01 to cook your potato. All right, so those are some examples of how to convert or how to calculate the cost of running a particular appliance or device.